Okay, continuing on with our lecture, so let's discuss about program comments and docstrings. So program comments are a piece of program text that the computer ignores but that provides useful documentations to programmers. And a docstring is a multi-line string of this form. So usually enclose this one in 3 quotation marks. So you have, this is a very long, basically paragraph, multi-line paragraph. So the program ignores this one, but it can be used as a message to to yourself when you are editing, or to to another programmer down the line can actually view your program. So another way to show comments are end of line comments. So usually begin it with the hashtag symbol. So for myself, I usually use this hashtag symbol because, well, instead of using the triple quotation marks, I'm just going to use a single symbol here. And aside from that, I can almost use this anywhere, provided that I can only limit my comment to a single line. So it can help explain the purpose of the variable or the strategy used by a piece of code. So as you can see from my code from the previous example, so I have the hashtag here. So tips related to comments and docstrings. So begin a program with a statement of purpose and other information helpful to programmers. And that doesn't include only other programmers but also yourself, because down the line, for example, you wrote a program and several years later you need to go back to that program, at least, or even within a few weeks, you will remember exactly what type that line is for, that program is for, that variable is. So they accompany a variable definition with a comment that explains the variable's purpose. Basically, these are a note to yourselves. It's like sticky notes. If you are fond of using bullet journals and other, well, journaling or planning, usually use sticky notes, tabs, indexings. Basically, these are notes to ourselves to give us an idea what the program is for. They precede major segments of codes with brief comments that explain their purpose. For example, when I'm writing a code, I usually indicate when I'm naming the variables that the next chunk of code are for this variable so and so, and the next chunk, this is for calculating so and so. So they include comments to explain the workings of a complex or tricky sections of code. So let's now discuss numeric data types and character sets. So the first applications of computers were to crunch numbers. So that's why we call them computers, because they are built, designed to compute. So the use of numbers in many applications is still very important. For example, I tend to use programming as a means to uh, actually calculate and provide graphs in some models of biological systems. As you can see from before, the KNF model, the the one with the longer code, that is from my study about the kinetic binding model. So these are part of the study, so that is how I use my programming. So in real life, the range of integers is infinite. So the computer's memory places a limit on the magnitude of the largest positive and negative integers. So this is the limit for Python. So integer literals are written without comma. So this is a numerical data type. So another numerical data is the floating point number. So real numbers, they have infinite precision. So that means these are not whole numbers. You have your since this is a float, this is you have decimal points up to 16 digits. So Python uses floating point numbers to represent real numbers. So another floating point number is your decimal notation. So this is your scientific notation here. So Python recognizes the scientific notation commands. So in Python, character literals look just like string literals and are of the string type. So they belong to different character sets, and among them ASCII2 and the Unicode set. So we have the ORD and CHR functions to convert characters to and from your ASCII2. And then we have the expressions. Expressions, they are a literal that evaluates itself. So the variable reference evaluates the variable's current value. So expressions provide an easy way to perform operations on data values to produce other values. So these are arithmetic expressions. Oh, by the way, in Python, we are using double asterisk to denote exponents. And then this division sign for basically for division, but a double slash for the quotient, and then we have the remainder sign. So precedence rules, we are using PEMDAS here. So exponent has the highest precedence and is evaluated first. Unary negation is evaluated next, and you have your division, multiplication, and of course the remainders, which are evaluated before your plus and minus. And the last one is the equal sign. So they are right associative. For example, you can write, let's see a tower spider so that you can see it more clearly. So for example, I want to write a code here. Okay, so I'm naming a variable a is 1. So I have a variable a is equal to 1. So I want to add another variable. Let's say, or rather, I want to increase the value of a. So a, increase it to a. I want to increase a by 1. Okay, and then let's print a. So it gives me 2. So when it said right associative, so that means if I have an initial value of 1 to a, and then if you notice, I use the same variable a all throughout here. Sorry. Okay, I use the same variable a all throughout here, and but the Python program accepts it. So that means it performs the expression on the right side first before performing the before doing or looking at the left side. So if you put it in the different way, a plus 1 is equal to a, it will give me an error. Okay, so that means what you put on the left and the right side of your equal sign matters. So let's go back to the lecture. Okay, sorry for the noise. So when both operands and expression are of the same numeric type, the resulting value is also of that type. For example, so you have your 2 integers, so the result is also another integer. If you have 2 floats, the result is another float. Now, what if you have a different value? So let's see. For example, here you have the integer 3 divide 4. It will give you a value of 0 because 3 and 4 is recognized here as an integer. But if you have 3 divide 4.0, so you have an integer and a float, it will give you a value, which is a float. So in here, in Python 3 specifically, if you have a different type, so you have an integer and a float, and you in a single expression you try to have an integer and a float, the integer is automatically converted to a float, so your result will have a float. Whereas if you have in Python 2, if you have an integer and a float, the float is converted to an integer, and that's basically, you can see the difference. So 0 versus 0.75. So mixed mode arithmetic involves integers and floating point numbers. So you must use type conversion factors when working with input and output of numbers. So the input function returns string as its value. So you must not use int or float function to convert the string to a number before performing arithmetic values. So you have, for example, an integer, and this is a float value. So if you have a string, even though it's a number, it's recognized as string. So another value. So here, if we convert, for example, this float value 6.75 to an integer, it doesn't round off the value, or rather round up. It just um, it just cuts the value along the decimal point. So I just remove anything beyond the decimal point. So even though if you have 6.75, if you convert 6.75 to an integer, it will give you a value of 6 because it will ignore whatever is beyond your integer, your decimal point. Whereas you use the function round, so it will round off the number. You will have 7. So please take note of those um, characteristics in Python, especially with the integers and the float, because again, it might look very miscellaneous or simple, but it can mean a lot, especially when dealing with large numbers, where precision and accuracy is very important. So we have type conversions. It also occurs in the construction of strings from numbers and other strings. So if you have, for example, we have the value 1000.55 given to the variable profit. So we have a dollar sign. So you cannot concatenate a string and a float objects. So you just use, you first need to convert the string, or rather convert the data, the numerical data, to a string before concatenating it. Unless you use a comma instead of a plus. Okay? So this is one of the quirks of your Python. So Python is a strongly typed programming language. So another thing about Python is that it's modular. So we have many useful functions which are organized in libraries of code called modules. Sometimes you can look it up as packages. In fact, if you are more familiar with the Python or programming in general, you can have the pip. Pip is the Python package installation program in Python. So you can, using pip, you can install packages. You can download packages from the net. So what are those packages? NumPy, Matplotlib, Pandas. So those packages are specifically suited to perform specific functions. And this is also one of the reasons why Python is a widely used program, for especially for beginners, because it allows collaboration. So different people develop different programs that they need and then share it with others. So for instance, you have your pandas. Pandas is specially designed for statistical analysis. So if you want to perform a specific statistical calculations, you need to import your pandas library. And well, as you can see from the code I showed you in the previous video of this lecture, so I'm using NumPy for usually number arrays, and for Matplotlib for my plotting. So we have a function. A function is a chunk of a code that can be called by a name to perform a task. So they often require arguments or parameters. So for example, round or even import, that is a function. So it's a command. So when a function completes its task, it may return a value back to the part of the program that code. So for example, round. Round is a function. So we want to know, or rather even help. Help is a function. So it tells the purpose of help is of course to provide information about whatever is asked for help. For example, we want to know what round is. So we want to know, or we call help in round. Round is also another function. So round, so this is a built-in function in Python. So this is your arguments or the parameters that you have. So in round, you input your number, and or if you have certain number of digits. You want to specifically round off it to the 3 decimal places, or for example 2-digit number. So it gives you the round off of that. So another one or rather, let's look at modules this time. So functions and other resources are coded in components called modules. So these functions like the ABS, the absolute value, and the round are from the built-in module, are always available for use within Python. But if you want to use more complicated functions, you need to install the specific module or the package that houses that. The math module includes functions that perform basic mathematical operation. So here, if you want to get a resource from a module, it's usually followed by a dot and then the name of that, the function within that module. So you have the pi and the square root functions. Okay, so you can actually, if you look at the code again from our previous uh, citing, so we have here. So again, these are the modules, the numpy and the matplotlib that I imported. And in order to call the function here, this is my function once. So since once is not within Python but within the module numpy, so I need to call first the module followed by the dot and then the specific function in that module. Okay, so you have that. And then have so anyway, let's go back to our presentation. Okay, so we have you can avoid using the qualifier with each reference by importing the individual resources. So from math, import pi sqrt. So that's another way to look at the importing specific functions or part of that. So instead of just having import, so this is another way to do that. So you are just getting specific functions from the math module. So if you want to import all of that, we just use asterisk. So that denotes everything, every function from the math module. And then the main module. So in the case study, actually in most studies that you have. So to differentiate the script from other modules in a program, we have the main module. So the main module here, for example, in my program, so my main module is basically, this is my main module. So this here is the main module, the body. And these are miscellaneous. The numpy and the matplotlib are just the miscellaneous modules I used to actually create my program, or rather to call or to use the commands in my program. So these are the usual format. So I usually do not add my name, but in my program here, so the main flow of what a program is supposed to be. So for example here, so I name my model the KNF pentamer model best fit. So and then after that, I first import the modules that I will need, so that I won't have to import it in the middle of my code. So basically, just like how you would cook something, or when you are creating an arts or crafts project, you need to first gather all materials. And in my case, the materials here are your modules. So import my modules, and then define my variables, perform my operations, and basically the code for my output. So here, add the next label, add the Y label, titles, legend, etc., etc. So these are for the data, output data. So basically that's the Python, the general, very simple program written in Python. So let's go back to the presentation. Okay, so that's it for the lecture. So we will look at loops, for the loops. Yeah, the next lecture about loops.